Your software keeps breaking, nothing ships on time, your customers find bugs before you do, and the simple change somehow takes a month. And while it is tempting to blame the developers, the technology, or the budget, this happens to many teams for the same reason almost every time. So let me show you the real reason why software keeps breaking and what it should look like instead. My name is Matt Kupczyk and I'm a founder of Brival, a senior-led software engineering practice. Over the last decade, we've built and modernized software for more than 100 companies, from startups to enterprises. And what we've learned from doing it is that coding is not the hardest part, but shipping software is a much wider process. The odd thing is that none of it is new. The way good software actually gets shipped hasn't really changed in decades, and AI didn't really turn it upside down either. If anything, it just made the discipline cheaper to reach. The shape has been well understood for years, and yet most teams still don't run it deliberately. They run it on instinct, which is exactly where it breaks. So in this video, I want to break that process down, stage by stage, describing what each one's for, what breaks when it's missing, and how you can actually handle it. Whether you're non-technical and you want real oversight of what your team is building, or you're technical and you want to compare how you work against how we do, this is our map. Let's start with the pattern, because we see it again and again, especially at smaller companies. The business talks to the developers. Sometimes there's a designer in the mix, maybe a manager in the background, but mostly it's here's what we need, and off they go. And here's what tends to happen. Things get built, and then the business finally sees them and goes, oh, that's not what I meant. And you need to spend more time fixing the solution instead of doing it right the first time. Bugs don't get caught before the release. They get caught by your customers, which damages the reputation of your business. Another one is that the structure underneath, the database, the architecture, gets you from point A to B just fine. But the moment you need to get from B to C, it needs to be torn up and redone. The last one is full dependence on individual. The whole process lives in one person's head, becoming the bottleneck for everything. Or the quality and the speed differs significantly depending on who happened to pick up the task. And these rarely show up one at a time, because in most companies we've worked with, it's all of them at once. Put it all together and the work just drags. Releases are unpredictable, they take forever, and what ships is a coin flip on quality. Now, here's what all of those have in common. It isn't that the developers are bad, it's that there's no process. The work isn't standardized, it lives in individuals, not within the company, which means the business has no real oversight and no real control over its own product. And this is the problem. Now here's what we can actually do about it. This is the process we use on every project. We call it the software delivery flow. It's not a textbook theory. It's the set of steps we've watched hold up project after project across startups and enterprises alike. Where many teams go straight from the business to a developer, this runs the work through 7 stages and loops the last one back to the first. So let me walk each one. First, strategy. It makes sure everyone knows why we are building something before we build it. The goal, whose it's for, what better actually means. It's the reason behind the feature and not the feature itself. In our story, the work got handed over with a what, but with no clear why. So the team had to reverse engineer the intent and build to a guess. Handling it is often relatively simple. For every request, you write the goal and whose it's for straight into the ticket before anyone starts. This is also where you set the quality bar. How much care this particular thing needs. A throwaway experiment and a system that moves real money don't deserve the same rigor. Second, requirements. They make sure that why turns into something the team can actually build and the business can actually check. Oftentimes, when a new screen gets built, nobody asks how it fits the features already there, so the product drifts into whatever the developer guessed, and it has to be redone. So you need to write down plainly what the expected new behavior is and how the current behavior needs to change. Say we submit a form. Where does that go? and what needs to happen next. Should we store it in our database and send an email, or just post it to our CRM? Clarity and precision are extremely important here. There are a few standard ways to do that. You can write a user story, which is just one sentence. As this kind of a user, I want to do this to achieve that. Or you can map the customer journey, which walks through the steps person takes from start to finish. Or you can use event storming, where you map out everything that can happen in the system. And it honestly doesn't matter which one you use. What matters is that the expectations are on paper, not in someone's head. Third, architecture. It is the structure underneath the product, how the data is organized, how the pieces talk to each other, and what the whole thing is built on. Good architecture is what keeps the change from breaking 5 other things, and what lets you keep building as the product grows. Handling it means asking hard questions about the future and deciding that structure on purpose. And this is senior work. AI will hand you knowledge for free, but not the judgment to weigh the trade-offs. That still comes from experience. Fourth, coding. It is the part everyone pictures, actually writing the software. Its goal is to make sure the code gets written to one shared standard so it stays consistent no matter whose hands are on the keyboard. Oftentimes there's no standard, so everyone does it their own way. Quality swings person to person, and the code base slowly becomes something only one person could safely touch. A standard is just the team agreeing on how things get done, where the code lives, and how every change is tracked, the naming and structure conventions everyone follows, and how much testing ships with each feature. Then you add guardrails, automatic checks that stop anything not meeting the standard from getting in. And finally, you write all of it down right in the codebase, so the team and the AI doing the work follow the same rules. Fifth, quality assurance. It makes sure problems get caught before your customers do, and that the thing actually works and keeps working. In this story, the customers were the test team. Even worse, the business assumed someone was testing, so everyone felt safe right up until it broke in front of a user. There are 3 ways to prevent it. First, manual testing. You need someone, ideally another pair of eyes, not the person who built it, to actually go through the work before it hits production. Second, written test cases. There are just scenarios. What to click and what should happen, written down so testing is predictable and anyone on a team can repeat it. And third, automation. You hand those test cases to a robot that runs through them automatically on every release, which frees a person up to focus on the edge cases. Sixth, release. It's the act of pushing your changes live to customers. It makes sure a change gets to production safely and predictably. Everyone's nightmare, someone deploys on a Friday, alone, unannounced, and when it breaks, there's no tested way back. So first, you need to pay attention to communication. You agree what's shipping and when, and never do a release without a sign-off from QA and the business. Second, you should keep the releases small and frequent instead of a big quarterly rollout. Smaller means less can break at once, and going back is cheap. Lastly, you automate the steps as much as you can, so shipping is repeatable instead of a heroic effort every time. And remember to always test your backups and your rollback strategy, which allows you to undo a failed release. And last, monitoring. It is how you know what's actually happening once the software is live. It makes sure you find out the system's up and that business is actually working. The expensive trap isn't the site being down, but is the site being up while orders silently fail and the dashboard stays green. So you need to watch 2 layers. First is technical health. It's up, it's fast, it's not throwing errors. And the second one, above it, is business health. Are people actually signing up, ordering, finishing what they came to do? Then you set alerts, which are just automatic warnings when something crosses a line, such as 0 completed orders in 12 hours. You should also agree with your team on the incident path, who gets notified and who fixes it, so a crash isn't improvised chaos. And then you block 30 minutes each week to actually look at the numbers and act on them, rather than waiting for escalation. So that's the whole flow. All 7 stages, strategy through monitoring. But just knowing these stages is the easy part. Whether they actually work for you comes down to a handful of things that have little to do with the diagram and everything to do how you run it. Here are the ones that matter most. Number 1, it's about ownership, not headcount. This doesn't have to be 7 people, but it's about every one of these blocks being owned. Many times the problems here don't start with talent problem, but a clarity problem. Number 2, because it's a process, you can measure it, which is how you actually steer it. Every block has a number, how many features get reworked, how many bugs reach customers, how many releases go messy. You don't need a dashboard empire, it's enough to pull a handful of numbers and talk through them with dev team regularly. Number 3, in the era of AI-assisted development, quality stopped being a budget question and became a question of putting attention in the right places. Owning the process end-to-end used to take a big budget and a big team, but it doesn't anymore. And the last one, number 4, this is the whole game. AI is a multiplier, and the multiplier works on whatever you feed it. With vague requirements and no standard, it will produce low-value work just 5 times faster. When you feed it with real discipline, a clear why, a sound architecture, a standard it can read, I've seen a single strong engineer outperform a team of 3 or 4 at the quality most companies couldn't afford 2 years ago. So that's what it looks like when software is built on purpose instead of in instinct. Not handed to a developer and hoped over, but the process the business can actually see and steer. If this was useful, it is the kind of thing we publish regularly. How to build high-quality software and how that's shifting in the era of AI. Subscribe to this channel so you can catch the next one. And if you want more, visit our website, brival.co, and sign up to our newsletter. That's where we go deeper and share the numbers behind our work.